for you tonight that's going to take advantage of the algebraic properties of what we call elementary symmetric polynomials. Now I've defined those here. Sigma 1 is equal to x plus y plus z, and notice that's one of the equations in this 3x3 system. And then sigma 2 comes up, this particular polynomial comes up when you actually square sigma 1. And similarly, sigma 3 will come up when you cube sigma 1. All right, and there's known relationships between these so-called independent, algebraically independent substitutions. So that I'm going to solve this problem utilizing those properties. Now, let's see. Now, again, we're actually trying to find x, y, z, and we gave that a name. We won't really use the name that much, as you'll observe. But right here, when I say verify this, sigma 1 is defined to be x plus y plus z. Now, it's not too hard to see that when you square that out, sigma 1 squared just means x plus y plus z squared. Now, it's very easy to believe that x squared, y squared, z squared will pop out of there. But what's going to happen is the xy cross terms, the yz cross terms, and the xz cross terms will happen twice. Now I didn't go through all of that work, but when you expand this out, you would end up with two of these terms right here, two of these sigma 2 terms. And so that's why x squared plus y squared plus z squared is equal to sigma 1 squared minus 2 sigma 2. That's important because you see, we know what x squared plus y squared plus z squared is, okay? All right, and so what we actually do is just make the substitutions. If you trust this result right here, you can replace x squared plus y squared plus z squared with the 14 that you see right here. Sigma 1 is given. This piece right here, x plus y plus z, that's equal to sigma 1 by our substitution scheme, right? Our substitution scheme calls this x plus y plus z. And so sigma 1 is 6, x squared plus y squared is equal to 14, and that explains how we get sigma 2 equals to 11. Okay? All right, so really all we need to find now is sigma 3. Now, a lot of the work is getting left out right here, but I at least wrote down how we arrived at it. Sigma 1 cubed is x plus y plus z cubed, and it's all of this stuff right here, okay? And notice the 6xyz is present, which is what we're trying to find. We're trying to find x, y, z, right? So, but if you'll notice right here, these terms look a lot like what happens when you multiply sigma 1 times sigma 2. And again, I left out the details there. This is easy to do, just tedious. Sigma 1 times sigma 2 is just this x plus y plus z times these three terms right here, okay? And so you get almost what you're looking for. You see how all of this information right here is exactly what you have right here. So that's where this sigma 1, that's where that piece comes from, okay? Now, again, you see how I'm making substitutions to kind of hide the tedium of all the algebra that's going on. But we're in good shape right here because we know that sigma 1 is 6, so we have 6 cubed right here, right? 6 cubed in that position, right? And then x cubed plus y cubed plus z cubed is given to us as 36, so I'll place it right there, right? Okay, and then I have this on the next screen, so I'm not going to go through all the arithmetic. But we know that sigma 1 right here is 11, right? We just found that right up here. That's 11. Okay, and then we also, sigma 1 is 6, I'm sorry. Sigma 1 is equal to 6, folks. Sorry about that. Let me erase that real quick. Sigma 1 is actually equal to, hang on just a minute, I'm trying to get my pencil back. Okay, Sigma 1 is again given to us as 6 right up here. That's sigma 1. So let's put a 6 right here. Okay, and then sigma 2, we calculate that earlier, is 11. Okay, it's actually 11. All right, again we computed that right here. Now let's just go to the next screen. I didn't do all the arithmetic on the screen. I just did it on the next screen. So let's clear this out. And let's move along to the next screen. And y'all, there's the calculation for you, nice and neat where you can see it. And so you get x, y, z is equal to 6 without even knowing what x, y, z is. I thought it was kind of interesting. I mean, the product x times y times z is equal to 6 without knowing what x is, what y is, or what z is. Now we could use what we call Vietas to actually figure out what x and y. That could be another question, and we've done enough work here to actually compute the value of x, y, and z. It's probably something easy like 1, 2, 3 permuted 6 ways. You know, they didn't go to a lot of trouble on this problem to make that. You know, sigma 1 is 6, and then you know, that's always a little bit of a letdown for me. I'm thinking about composing some problems where this kind of disappointing outcome doesn't occur. But anyway, that is, rest assured, this is the result. It's the solution that was sought after. Let me know what you think.